Ever wonder how AI catches harmful content online, like hate speech, scams, or dangerous misinformation, without accidentally flagging harmless posts? It's trickier than it sounds, and this research shows why. Let's break down how scientists are training AI to stay one step ahead of bad actors. Imagine teaching a robot to spot trouble. You want it to catch obvious red flags, right? But what if someone hides their message using slang, typos, or code words? That's where evasion cases come in, examples of sneaky tactics people use to bypass detection. Researchers tested AI models by training them with and without these tricky examples. And the results? Models trained on evasion cases crushed their counterparts. Take the QN2-53B model. When trained without evasion cases, it scored a 0.76 F1. Think of that as a mid-range grade. But with evasion training, it jumped to 0.85, like acing a tough exam. And bigger models. The 7B version of QN2-5. It nailed even more nuanced tasks, like avoiding false positives. Size matters, but it's not the whole story. Here's the twist: the data the AI learns from matters just as much. Researchers generated fake, but realistic harmful content using structured templates. They mixed in things like fake user profiles, tricky language patterns, and even code words. But not all data was equal. A model trained on data from GPT-4o outperformed one trained on DeepSeek R1 data, like using a high-quality blueprint versus a sketchy one. This isn't just about brute force. The templates act like a detective's toolkit, simulating real-world challenges. They test everything from, what if the user is a new account, to how do subtle insults hide in jokes. By mixing these elements, researchers create a virtual playground to stress-test AI. The goal? Build systems that adapt to evolving threats, without risking real users. Now let's zoom out. Online platforms face a unique challenge. Harmful content evolves faster than traditional filters can adapt. That's where ChineseHarm-Bench steps in, a groundbreaking toolkit designed specifically for Chinese online spaces. But how does it work? First, researchers built a massive dataset. Think of it as a treasure chest of online content. They used k-means clustering to group similar posts, feeding text into BERT, a language model that understands context. This sorted content into 100 clusters, from which they sampled 20 examples per category, totaling 2,000 labeled posts. But raw data isn't enough. Here's the clever part: human experts refined the dataset. 3 native Chinese speakers reviewed content, not just labeling it but creating rules to guide AI. For instance, if a post matched a rule like contains hate speech, it stayed in the dataset. If it didn't fit but still belonged, they updated the rules. This back and forth ensured the dataset was diverse and balanced. No category got left out. Now, how do you test if AI can handle this? The team used a zero-shot setup. Models weren't trained on this exact data. Instead, they were given prompts and asked to classify posts. The results? Even top models like GPT-4o and DeepSeek R1 struggled. Why? Because harmful content is always evolving. Users find new ways to sneak past filters, like using emojis or tricky wordplay. But here's the twist: the researchers didn't stop there. They created synthetic data, AI-generated examples that mimic how bad actors hide harmful messages. Think of it as training wheels for AI. A big model like GPT-4o generates fake posts, which are then refined by human experts. This synthetic data isn't just random. It's designed to simulate real-world evasion tactics like homophones, piano instead of mother, or cultural references. So why does this matter? Online safety isn't a one-size-fits-all game. Harmful content keeps changing its tricks, and this research shows how we can train AI to keep up. It's not just about spotting the obvious, it's about preparing for the unexpected. And that's what makes these models smarter, safer, and more reliable for all of us. Next time you see an AI flagging a post, remember, it's the result of clever training, tricky simulations, and a whole lot of data science. Stay curious and let's keep building a better internet together.